Okay, hello everybody, and for this video we have integration by parts. Okay, and instead of just telling you what integration by parts is, I think I need to start with something that I'll call the first question. All right, and we've got to agree about the first question before we can move on and learn what integration by parts is. Okay, so I ask you, is it true that the antiderivative of a function f times a function g is equal to the antiderivative of f times the antiderivative of g? And no, definitely not. I mean, for derivatives, isn't there a special rule for the derivative of a product? So yeah, there's the product rule. That's what you use. Same thing is true for antiderivatives. Okay, there's a rule for this situation, and you can't simply do it like that. The rule is integration by parts, and it's derived from the product rule. Probably won't surprise you. But let's agree about this, that we're not going to do the problem this way, okay? So when we're going to do, so what's the antiderivative of x times sine 3x? We're not going to work those individually and just multiply them together, all right? It just doesn't work that way, and that's what I'm trying to establish in this first question. The second question then is, how do we integrate the product of two functions? Okay, if you can't do it like this, it's natural to wonder how you're supposed to do it. Okay, that's what integration by parts is. All right, so here's the formula, and I put that in pencil, and in green are some notes or things to realize about it before we start trying to use it. Okay, so here's what it says. It says the antiderivative of f times g prime is f times g minus the antiderivative of f prime times g. So when you're given a problem that's the antiderivative of the product of two functions, you'll have to decide which one of those you're going to call f and which one you're going to call g prime. And throughout the video, I'll talk a little bit about how you make that decision. But it's a coin flip, isn't it? There's only two choices, right? One of them's f, one of them's g prime. If you happen to get it wrong, your first choice, you can try it the other way. But let's say that yes, you'll have to decide. Here's where your answer is, but you'll need to work that part out. Okay? So hopefully this will break down in a way that that one is easily doable by some method that we already know. Okay? All right, so there's your integration by parts formula. You're looking at it. We start with something like this. There's a product right there. We make a decision about which of the functions is f and which is g prime, and then we carry on and evaluate that to our answer. Okay, now I can only explain it so much just by showing that formula. I have to give you an example, and so here's the example I wanted to do right here: x times sine of 3x. All right. But before I do that, I'll say that just as a matter of fine print, integration by parts is sometimes written using differentials like that. It's really the same thing. There's a function u and there's a function v, and there's u and dv. dv is the derivative of v, and for the function u, du is the derivative of u. It's all the same thing. It really doesn't matter. So I'll probably write it the other way. Okay. So say we want to do this problem here, and I tell you this just to get started, just to make it easy. I'll say we'll use integration by parts, and we'll choose this way. We'll let f of x be this function x, and we'll let g prime be sine of 3x. Okay? Now, what did integration by parts say our answer was? It says it was f of x times g of x minus the antiderivative of f prime times g. Okay? So I told you, let's go ahead and use this choice. What else do we need? Well, I chose f of x to be x. I also need f prime. And I chose g prime to be sine 3x. I also need g. Okay? So in addition to these, we're going to have to figure out f prime and we're going to have to figure out g. Okay? All right, so think of it like this. If f of x is equal to x, what's f prime? That's just 1. And if g prime is sine 3x, what's g? That would be negative 1/3 cosine 3x. Okay? All right. What's the story behind that? Well, this is the antiderivative of sine 3x. In general, it's going to be the antiderivative of g prime. Okay? I mean, because look, the derivative of g is supposed to be g prime. Let's go ahead and check that. Like, what's the derivative of cosine 3x? It's going to be negative sine 3x times 3, according to the chain rule. But the negative 3 and the negative 1/3 cancel. It'll give me sine 3x. Okay? This is a u substitution problem. If you have to work this out separately, then you go ahead and do that. But that's a u substitution problem where u is equal to 3x. That's how you do just that part, just to figure out g. Okay, we covered u substitution elsewhere. I have to refer you back to those videos if you need some more details or some more practice. All right, so I think I have it then. Let's see. All right, here's your answer to this. It's f times g, so I get negative 1/3 x cosine of 3x. That's f times g. And then minus the antiderivative of f prime times g. So f prime is 1 times g, so that's going to be negative 1/3 cosine 3x dx. Okay, there we go. Now, we can complete this to our final answer if I can work this out. So in order for me to do that, I'll do a few things. Okay, so first, there's nothing to do with this. We're done with that, and that's going to be part of our answer. But for this, that constant of negative 1/3, I'll pull out to the front of this, and it'll make plus 1/3 times the antiderivative of cosine 3x. Okay, so that is something that is easily doable. It's kind of like this problem. It's a u substitution problem, all right? So say I do that by u substitution in the same way that I would do this one by u substitution. Then here's what I'll get. Negative 1/3 x cosine 3x plus 1/3, and then my antiderivative of cosine 3x is going to be sine 3x over 3. Okay? All right, and so there's my answer. Me being able to solve that integral right there took me to my final answer. Let's go ahead and give the final answer like this. Let's say negative 1/3 x cosine 3x, and let's put that as a ninth right there. 1/9 sine 3x plus c, and then we're all done at that point. Okay, so that's basically how integration by parts is going to look. It starts by realizing that we have a product, and I'm not saying every problem where the integrand here is a product is done using integration by parts, but for now, those are the ones we're going to see. We have to choose what f and g prime are. I did that part for you this time, but we'll talk about how you make that choice. Then we find the rest of what we need, which is f prime and g. Finding g involves another antiderivative, right? All based on what g prime is. But once we get all that, we put it in. Hopefully we can work this part, right? And if we do, we get our final answer. There you go. How do you know that's right? How could you check it? Well, this is the antiderivative of that. So if you took the derivative of this, then you would find it takes you back to x times sine 3x. If you were inclined to check it, that's what you'd do. Okay. Now, here I made that choice for you. How might you go about making the choice when you use integration by parts? So let's talk about a way to make the decision. So here's the integration by parts formula. That's the one we just used. How do we decide of the two functions that are there, which one is going to be f and which one is going to be g prime? So here's probably the most common way people do it. They use this thing called Ilate. And here's how that works. Every letter in this acronym stands for a type of function. I stands for inverse trig functions. L stands for a logarithmic function. A stands for an algebraic function. T stands for trig. E stands for exponential function. As you decide which kinds of functions you have, you read this left to right, and the first kind of function you come to that you have is f, and the second is g prime. Okay? So let me show you by example how to use this. So let's do this problem here. Okay? So what's the antiderivative of x times natural log of x? All right? So let's do like this. Okay. So Ilate, okay, and I have this time an algebraic function, x, and a logarithmic function, natural log of x. And I said as you read this left to right, you choose f, and then you choose g prime, okay? So that means, as I read this left to right, L is the first letter I get to. That's my function f. It's going to be the logarithmic function. And A is the second letter I get to. That's algebraic. G prime will be the algebraic function. Okay? So here's our choice. Here's how we're going to apply the integration by parts formula. F is going to be the natural logarithm. Okay? And G prime is going to be the algebraic function, which is x. Okay? All right, now we need more than that. We also need f prime, and we also need g. All right? What's the reason? Well, because here's the formula. F of x times g of x minus f prime x g of x dx. Okay. So we've got to complete that. And I've started with my choice. So we'll find f prime. Let's see. If f of x is natural log of x, what's f prime? It's going to be 1 over x. And if g prime is x, what's g? That would be x squared over 2, right? Just check and make sure it's consistent. If f is natural log of x, is f prime 1 over x? Yes. And if g is x squared over 2, is g prime going to be x? Also yes. Okay? All right, so that looks like enough. Let's see, here's what we get then. F times g, that will be 1/2 x squared natural log of x. Okay? And then minus the antiderivative of f prime times g. So that's going to look like 1 over x times x squared over 2. Okay. And then we need to be able to work this. All right. So let's simplify a little bit. Let's see. 1/2 x squared natural log of x. I can't do anything with that. Here I can take out a factor of 1 over 2, so I'll go ahead and do that. And here, the 1 over x and x squared, those reduce to just being x. So yes, I'm able to work that. That's about as easy as integrals get right there. All right. So here's what we'll get then. 1/2 x squared natural log of x minus 1/2 times whatever the antiderivative of x is, which is x squared over 2. And then we put our constant of integration. Final answer, let's see. 1/2 x squared natural log of x minus, well, let's say 1/4, right? 2 and 2. 1/4 x squared plus c. Okay. So now you get a pretty good feel of how integration by parts works. We'll probably use this to make our choice. Write it down. Circle which kind of functions you have. Choose by reading left to right in order of f and g prime. Then the rest of it you find by derivatives or antiderivatives and put everything into the formula.